Hello everyone, my name is Sabina Gera and I will briefly tell you something about the topic depleted uranium effects in air, water and soil, which is processed within the Module 5. The objective is to gain a fundamental understanding of the presence and effects of depleted uranium in the environment, including its occurrence in air, water and soil. The course will provide students with an introduction to the sources, fundamental behavior and effects of depleted uranium in the environment, including air, water and soil. I really hope that upon completion of this module, students will have acquire the knowledge and skills necessary to define the sources of depleted uranium to the environment and identify the most common route of exposure to depleted uranium in the environment, as well as to describe the depleted uranium effect in the environment and to recognize the depleted uranium effect in the environment. In order to understand the fate and transport of depleted uranium in the environment, we need to define the basic terms, concepts, and definitions related to sources of uranium to the environment and routes of exposure to depleted uranium in the environment, and also to say something about the impact of depleted uranium on the environment. The of the environment by depleted uranium can occur in a number of ways, including through soil water biota as well as airborne particles. While there are notable differences in the radiological properties of uranium isotopes, their chemical behavior is essentially identical. It can therefore be concluded that the knowledge gained about the transformation, transportive fate, and effect of natural uranium in the environment can be the same for the depleted uranium. Uranium is a naturally occurring element that can be found in a variety of geological, environmental, and biological materials. Metallic depleted uranium exhibits the same chemical reactivity as metallic uranium, which is regarded as a highly reactive material. Depleted uranium has a multitude of civil and military applications, including use as counterweights for aircrafts, alloying of special steels, catalyst applications in the oil and gas industries, oil wells, sinker bars, and radiation shielding. The military application of depleted uranium include the use of depleted containing munitions and the incorporation of depleted uranium into protective armor for tanks. Uranium is invariably present in surface water and groundwater. The concentration of uranium in natural water varies from one region to another due to the different geological composition of aquifer, the chemical composition of the water, the distance from uraniferous areas, and prevailing climatic and agricultural conditions. It can be observed that atmospheric releases of depleted uranium are almost exclusively the particular form, as the vapor and gas forms of depleted uranium are not commonly encountered. The high of depleted uranium in most particular forms restricts the transport of depleted uranium in the atmosphere to relatively small particles. The release of depleted uranium into the atmosphere can occur via the emissions of particles from stacks, the resuspension of soil, or the emissions of fugitive dust from piles or industrial processes areas containing depleted uranium. The reported background levels of uranium in the air exhibit considerable variability. For example, the World Health Organization cites values in ambient air ranging from 0.02 to 0.076 nanograms per cubic meters, while the United States National Council on Radiation Protection and Measurements and the United States Environmental Protection Agency report background concentration of 0.30 and 0.15 to 0.40 nanograms per cubic meter respectively in 51 urban as well as rural areas across the United States. A significant proportion of the data pertaining to uranium concentration in the atmosphere has been derived from the mining of uranium and from industries such as the fertilizers industry, in which uranium-rich dust may be produced. The concentration of uranium in soil exhibits considerable variability, as I said. This reflects the abundance of uranium in the parent geological materials from which the soil were formed, the processes of soil development, including leaching, and the addition of uranium from anthropogenic activities, such as the application of fertilizers or military conflicts and training. Uranium is a naturally occurring element that can be found in a variety of environmental matrices, including water and soil. As a consequence of its omnipresent distribution, humans are exposed to minute quantities of natural uranium on a daily basis through ingestion and inhalation. Excess loading can occur through three exposure pathways: inhalation, ingestion, and thermal contact. However, the latter is typically regarded as an insignificant exposure scenario. Inhalation of depleted uranium aerosols is considered the most hazardous pathway for depleted uranium exposure when considering the protection of the public from radiation. Depleted uranium rounds that melt during penetration of hard targets from a hot aerosol, which is rapidly ignited when it comes into contact with the air. The distance that these aerosols can be transported depends on the size distribution of the particles. In the event of contamination by depleted uranium, resuspension in the atmosphere may occur as a result of wind or dust disturbances associated with the site operations. In addition, accidental inhalation may result from the fires in depleted uranium storage facilities, aircraft crashes, the manufacture of armor-piercing weapons, or the contamination of the contaminated objects. Furthermore, briefly about the impact of depleted uranium on the environment. The environment impact of depleted uranium is contingent upon the specific circumstances under which depleted uranium ammunition is employed and the physical, chemical, and geological attributes of the environment in question. Once depleted uranium aerosols have settled on the ground, the depleted uranium particles combine with other material and increase in size, thereby reducing the inhalation hazard. Depleted uranium present in the soil has the potential to migrate to surface and groundwater, subsequently flowing into water streams. Furthermore, plants would also take up depleted uranium present in soil and water. The presence of depleted uranium in soil will result in its oxidation and solubility, allowing for migration to surface and groundwater and subsequently incorporation into the food chain. Thank you for your attention.